Historically, the biggest empires always had the biggest navies or the biggest armies, the most ships, the most men, or both. And in the modern age, science and industry have repeatedly pushed the limits of men, technology, and imagination in the pursuit of that power. More often, not by creating bigger armies, but bigger weapons. From aircraft that defy gravity, tanks to field guns, bombers to battleships. The destructive capability of the machinery of war develops with each decade, each unique in their own way. The machines in this episode share two common traits. They are big and they are powerful. In World War I, guns began to assume monumental proportions. Big Bertha, the German siegebreaker, could hurl an 800-kilogram projectile 13 kilometers and was used to devastating effect in the early stages of World War I. But during World War II, a class of even larger supercannons emerged, and their psychological effect on the men facing them meant that, like Bertha, they all had personalized names. And one of the biggest was called Annie. Annie was one of 25 massive railway guns designed and built by the famous German Krupp Steelworks prior to the commencement of World War II. Designated the K5, they were developed to deliver shells capable of destroying the French border fortifications known as the Maginot Line.
The first objective was to deliver a large projectile containing a large amount of explosive to the target. The second objective was to provide range, and some of the quarter-of-a-ton projectiles were able to reach 50 kilometers.
Although they never saw service on the Maginot Line, they were involved in a variety of sieges. And for Annie, that most famously took place during the American invasion of the Italian coastal town of Anzio in early 1944. Annie was one of two K5s moved and hidden in rail tunnels, 18 miles above the coastline where the Americans had landed. From this vantage point, over 2 months, the pair rained down their massive exploding shells on the 70,000 Allied troops trying to break out of the established beachhead. It was during this time that the train-like sound the huge shells made as they passed overhead earned the guns the nicknames Anzio Annie and the Anzio Express. And the K5's 288mm caliber barrel was rifled with 12 7mm grooves, making it not just big, but extremely accurate. Each K5 railway battery consisted of 2 guns. Each gun had its own train, with engine and 6 rail cars. Ultimately, it was that size that proved her downfall.
For a railway gun, you had to lay tracks to get it to its destination. Now, not only was that intensive in terms of manpower, but also, inadvertently, what you did was, when you were laying these tracks, you were providing a path for the Allied bombers to track where that railway gun actually was. So its survivability was put into question by virtue of the fact of the tracks that it was running on.
The railway gun's great advantage of being able to use existing infrastructure to besiege armies was, paradoxically, its Achilles heel. when on January 20th, 1953, at the height of the Cold War, former World War II General Dwight D. Eisenhower became President of the United States. His inauguration parade included 65 bands, floats from the then 50 states of the Union, 22,000 servicemen and women, 350 horses, and a gun. A brand new 280mm cannon.
In the early 50s, they were exploring how to deliver nuclear payloads. And there was a series of tests in Nevada where they tested a variety of different delivery systems.
One of which was the M65 howitzer. With missiles capable of delivering atomic warheads, the most powerful weapons on the planet, in the control of the U.S. Air Force, the U.S. Army felt it too should have a weapon of similar force. And when in 1949, the U.S. Atomic Energy Commission announced the development of a 280mm caliber nuclear projectile, the Army set to work developing a mechanism to deliver it. The result was a self-propelled gun with an overall weight of 78 tons, a length of 26 meters, and a width of 5 meters. Advances in mechanics meant that, once in position, Atomic Annie could be set up in 15 minutes. And in May 1953, in the deserts of Nevada, the weapon was tested.
And they did actually fire an 800-pound nuclear shell from a 280mm artillery piece 7 miles in the Nevada desert to explode as a nuclear device. It's the only time, certainly in the Western world, that a nuclear shell had been delivered by a cannon.
Nine M65s were deployed in Europe to counter the Soviet threat. But Atomic Annie, like Anzio Annie, was a transportation nightmare. On the road, it resembled a large fire engine, with 2 prime movers using independent steering systems, one positioned at either end of the gun carriage. Its propensity to tip over earned it another less favorable nickname, the Widowmaker. Evolution sometimes heads in a direction that doesn't quite work, and nuclear technology did not find a natural place fired from a gun. As the end of 1962 approached, the idea of the stately and visible progress of an atomic cannon moving across the world as a crucial influence had passed. New weapons had been developed, and the Atomic Annies joined their cousins, the K5s, in retirement.
All were withdrawn from service, along with their 80-odd shells constructed for them.
What history has shown us is that power is not always about sheer size. The punch of a behemoth doesn't necessarily have to come from a behemoth. And in the case of the M777, while it is still a large weapon, 155mm in caliber, and with an overall length of 10 meters, the focus of its development was on reducing its weight, which makes it extremely powerful.
And it means that the M777 could be transported in a larger range of helicopters than its previous counterpart. And so, in that regard, it can be a much more deadly weapon because the military can get it to where it needs to be quickly.
The M777 tips the scales at just over 4 tons. To achieve this low weight, it applies the latest advances in metallurgical science, and its construction makes extensive use of a rare metal that has found numerous applications in the modern machinery of war: titanium.
Now, titanium has a density which is about half that of steel, but it's a very strong material. So it means that you can reduce the weight of your structure, but at the same time maintain strength that you need when you're dealing with the high shock forces when the gun fires projectiles.
Everything about the M777 is a stark example of more for less. It's operated by a crew of 5. Anzio Annie had a crew of 82. The M777 can rapid fire 5 rounds per minute. Annie fired one every 5 minutes. And while Annie was accurate, modern shells like the Excalibur take accuracy to a new level.
So the Excalibur is a shell which has a little sort of motor that kind of deploys fins on firing and can actually use these fins to intelligently guide the shell to its target.
A lightweight behemoth with incredible power and accuracy. One of the few things the M777 can't do is move itself. And a barrage is of little use if you can't press your advantage. To do that, you need to get up close. Necessity, they say, is the mother of invention. The mass of wire, mud, trenches, and modern weaponry on the Western Front during World War I had led to an appallingly costly stalemate, where success was measured not in kilometers gained, but mere meters. But on the 8th of August, 1918, at the Battle of Amiens, on a single day, the Allied forces moved 13 kilometers across German-held territory. And on that day, the battlefield hummed with the sound of over 550 of what would prove to be perhaps the defining weapon of the war. Tanks.
When the British were designing the tank in 1915, 1916, they were aware of the nature of trench warfare on the Western Front. And the reason for this large track design in that lozenge shape of the first tanks was to give the tank mobility. So if it came to the trench lines, if they were able to break through, is that they'll be able to cross them without falling into a trench and getting irrevocably bogged.
The 28-ton rhomboid-shaped Mark I tank first saw service on the Somme on the 15th of September 1916 and was not a huge success. Mechanical problems from what proved to be an underpowered and unreliable 78-kilowatt engine and crews inexperienced in handling the new weapon compromised the performance of the few that made it to the battlefield. And they were slow.
It actually was slower than an infantryman walking, which meant that rather than being the tanks advancing and the troops coming behind the tanks, it often meant that the troops went far in advance of the tank, which found it hard to keep up.
Noise inside the tank made it difficult to communicate, and as a result, some became hopelessly lost. Others ground to a halt, their crews rendered unconscious by the fumes of the engine, which sat in the middle of the fighting compartment without any cover or muffler. And they were prone to bogging in the muddy morass that was the Western Front. But development persisted. Adjustments to each variation were made based on combat experience. In the Mark IV, power was up to 15 kilowatts. Weight was down to 25 tons. Speed increased to 6.5 kilometers an hour. Continuous improvements that by 1918 saw the tank entrenched as a vital cog in the machinery of war.
You think of the emergence of the tank on the battlefield in the First World War. It's clunky, it's unreliable, the armour's perhaps penetrated by rifle or machine gun fire, but nonetheless it's this lumbering, terrifying beast of war you've never seen before. It has an immense psychological impact. And it becomes tactically very significant. As a soft, squishy infantryman with a rifle, you are absolutely outclassed by this giant land ship. And that remains true for decades.
And within just 2 of those decades, tank warfare reached its zenith with the outbreak of World War II and the famous German blitzkrieg tactics of 1939. A highly mobile and destructive all-arms method of fighting, led by the famous Panzer tanks. Blitzkrieg reshaped the battlefield, where previously emphasis had been on a smattering of light tanks and infantry support roles. The Allies now desperately needed medium tanks that could compete with and defeat the German panzers. But in tank design, the British had fallen well behind the game.
The British in 1918, it can fairly be said, were probably the leaders in tank design. However, the belief that tanks would be useful in European war, but probably not in the colonial warfare which the British find themselves doing in the interwar period, meant that they did not spend as much time looking at tank design as they did until probably late in the 1930s.
Outclassed and with limited time and limited resources, they turned to the Americans for salvation. They responded with the M4 Sherman, the most widely used tank by the Western Allies during the war. The design brief was simple: a medium tank with a 75mm main gun mounted in a full traverse turret. Fast enough to keep pace with the German tanks, with good all-round visibility and improved armor allocation. And it was needed almost immediately. To save time, the Americans incorporated the engine, transmission, tracks, and suspension systems of the M3 Lee medium tank. On that existing chassis, they put an all-new body with frontal armor that was not a patchwork of riveted plates, but a solid piece of cast homogeneous steel 50mm thick. To overcome the strength disadvantage of cast armor, the front armor plate was cleverly sloped to 56 degrees, creating a surface that would cause some incoming rounds to glance off. But more importantly, it increased the effective thickness of the armor on the horizontal plane to 91mm, almost doubling protection. Even so, against the heaviest of tanks, the Sherman was vulnerable.
Crews putting extra track on the front of their vehicles, they're putting extra sandbags on the front of the vehicles, and this is trying to retard an incoming armour-piercing round. Sometimes not to great effect.
Weighing close to 30 tons, the Sherman had a top speed of 40 kilometers per hour, meaning it could keep pace with its principal foe, the Panzer. And armed with a medium-velocity 75mm main gun, 2 anti-infantry machine guns, and a 50 caliber Browning anti-aircraft gun, they had the Panzer covered. But the Sherman's greatest strengths were its reliability and its numbers. Nearly 5,000 were produced, built by the giants of the American motor industry: Ford, Chrysler, and General Motors.
That whole Henry Ford type thing, the production line of cars, now applies to making a tank.
The Sherman's life was extended, seeing combat in numerous Cold War conflicts. But as anti-tank weaponry improved and the speed of warfare increased, the need arose for battlefield behemoths that were simply bigger and faster. And there are none bigger than the tank they call Whispering Death. The Cold War fueled an environment which led to the development of some of the most advanced weapon systems on the planet. And when in the 1970s, the US Army decided they needed a faster tank with exceptional firepower and unprecedented levels of crew protection, they took the best of the world's available military technology and created the M1 Abrams. Learning lessons from a variety of conflicts, they designed a tank that, despite weighing up to 70 tons in some variants, has a deceptively low profile. Standing less than 3 meters tall, the low height makes the Abrams a less obvious and less available target for enemy fire. Significant work has also been done to reduce the thermal signature of the tank, making it harder to detect. But if it is hit, it is constructed using the most advanced armor available.
The protection system of the M1 Abrams is fairly superior compared to a lot of main battle tanks. And certain variants of the M1 Abrams actually use depleted uranium in the turret. Now, depleted uranium is a very dense material, and that means it's able to provide superior levels of protection against a whole range of weapon systems.
It was also the first tank to use the British-developed Chobham armor, a complex laminate structure that combines an arrangement of ceramic blocks, metal plates, Kevlar, and open space to achieve a near-perfect blend of anti-penetration surfaces. In battle, the Abrams 120mm smoothbore main gun has been found to outrange any other tank in current service. And connected to the world's most advanced tank-based targeting system that monitors the tank's tilt, motion, and even the wind, it allows the Abrams to fire on multiple targets with accuracy while on the move. But what truly sets the Abrams apart is its speed, which can exceed 70 kilometers per hour. To achieve this, it uses a distinctive power source.
The use of the gas turbine engine in the M1 Abrams is fairly unique to main battle tanks. And the reason why they use a gas turbine is simply to reduce the noise and to give it the power it needs to accelerate such a heavy vehicle. This vehicle weighs up to 70 tons with certain variants, and so it's a very heavy piece of military equipment, and you need a substantial means of driving that forward.
It is the whisper-quiet gas turbine that has given the M1 its nickname. A power source that is normally associated with a very different kind of battlefield behemoth: aircraft. On the 6th of August, 1945, an event took place that would change the world forever. The heaviest bomber of World War II delivered a device that would create the biggest explosion mankind had ever experienced. Less than 30 years previously, heavier than aircraft had been little more than curiosities. But the aircraft that carried that fateful payload in August 1945 was a far cry from the timber and fabric of World War I. It was a heavy bomber that revolutionized military and civilian aviation. Militaries always want aircraft with increased speed and payload, but in World War II, what the Americans desperately needed was one with greater range to deal with the huge distances covered in the war in the Pacific. To achieve a lethal combination of speed, payload, and range, they based their designs on an aircraft that was already the supreme bomber of World War II, the B-17 Flying Fortress, and built the largest, most complex aircraft that had ever gone into production.
The Flying Fortress was a very capable aeroplane, but it was firmly rooted in the 30s, and it had been developed as far as it could realistically go. With the B-29, they designed it to do everything a Flying Fortress could do and do it all better.
The B-29 was a combination of cutting-edge technology and devastating firepower, wrapped in a massive package. Fitted with 4 of the largest radial engines manufactured in the United States, the supercharged 18-cylinder Wright R-3350 the Superfortress had a top speed of over 550 kilometers per hour and a combat range of 5,220 kilometers, double that of the B-17. And it was designed for sustained flight at what was then dangerously high altitude. As you ascend, temperature drops 1 degree per 300 meters. Without heating and oxygen, anoxia can result in death within 10 minutes at altitudes over 7,500 meters. To overcome this, the B-29 became the first production aircraft to feature a fully sealed and pressurized cabin.
It allowed them to fly routinely over 35,000 feet, where the air is thinner and therefore you can fly faster without putting as much strain on the engines to maintain the speed.
The B-29 was in every way a technological marvel. A systems-driven aircraft with over 10 kilometers of electrical cabling, part of which fed a state-of-the-art analog firing system that remotely trained the aircraft's 5 gun turrets on incoming targets, compensating for speed, gravity, and atmospheric pressure. Intercontinental range, payload, and versatility made the B-29 a game-changer that not only helped end the war, but paved the way for both the Americans and the Soviets to pursue even grander designs. Designs that would allow them to deploy greater payloads to war zones with unparalleled speed. It started a game of brinkmanship, a race to be the biggest, a race the Soviets would ultimately win. During the latter stages of the Cold War, when the Americans unveiled the massive C-5 Galaxy transport, the Soviets immediately countered and produced an aircraft that remains the largest airborne military transport vehicle in the world today. Known by NATO as the Condor, it is the Antonov AN-124. Big machines need a big aircraft to lift them. Designed to carry the largest Soviet tanks, troops, and support equipment and deliver them to a hotspot quickly, the AN-124 has a maximum takeoff weight of 405 tons with a payload of 150 tons. To put those weights into perspective, it can carry 2 fully loaded B-29s, throw in a fully loaded B-17 for good measure, and still have room to spare.
The design of large transport aircraft require the right combination of the design of a fuselage that can accommodate the potential payloads that may be required during its operation. Included in that is the access to the payload.
With a fuselage close to 70 meters in length and 21 meters in height, creating a cargo space 36 meters long and 6.4 meters wide, comparable in size to a bowling green, the sheer size of the aircraft presents a unique design challenge.
Larger fuselage will affect the aerodynamics of the aircraft, it will increase the drag of the aircraft, and so you have to balance that with wings that are large enough to generate enough lift, and also, quite principally, the engines that develop enough thrust to lift these aircraft.
To generate that required lift, the AN-124 has a wingspan of 73 meters. And with an upper deck that can accommodate 88 fully equipped soldiers, it can deploy a small army at over 1,000 kilometers per hour. The AN-124 is big and fast, but on its own, not lethal. The Tupolev Tu-160, on the other hand, is all three. Known by the NATO codename Black Jack, or the White Swan in Russia, the Tu-160 was the last bomber aircraft produced by the Soviet Union before its collapse, and is the largest jet-powered swing-wing combat aircraft ever to enter service. An aircraft again born of the military tit-for-tat that was the Cold War. when the Americans began developing a similar aircraft, the B-1.
The Americans were developing a supersonic swing-wing bomber that could quickly penetrate Soviet airspace. During that development, interestingly, the Americans actually decided perhaps that need wasn't there, and so the Americans actually cancelled the B-1A program. The Russians, however, continued with the Blackjack and developed that aircraft into a very capable, very high-speed, penetrating bomber.
All supersonic aircraft have swept wings. Put simply, the faster you go, the less wing area you need to generate lift. But at low speeds, that lift is greatly reduced. The engineering challenge was to produce an aircraft with enough lift to raise a serious payload, but one which could also reach speeds comparable to a modern fighter jet.
And one solution for that is so-called swing wings. During low-speed operation at takeoff and when you return for landing, the wings are swept forward so that they are what we call very high aspect ratio wings. And that configuration of wing is optimized to generate lift very efficiently, especially at low speeds.
The variable geometry outer tapered wings of the White Swan are able to be swept back from 20 degrees to 65 degrees, providing high-performance flight characteristics at both supersonic and subsonic speeds. And the tail surfaces, horizontal and vertical, are one piece and all moving for improved low-speed control. Equipped with 4 of the most powerful engines ever fitted to an aircraft, the Tu-160, which weighs 275 tons fully loaded, manages an extraordinary top speed of 2,200 kilometers per hour and climbs at a rate of 70 meters per second to a service ceiling of 16,000 meters. But while a behemoth in the air or on the land can be measured in terms of bowling greens, at sea, the word behemoth takes on a whole other meaning. For centuries, a nation's naval strength determined its place in the world. And as the centuries passed, ships slowly increased in size. But the Industrial Revolution sped that growth. Engines created a new source of power. Power gave rise to bigger ships with heavier guns, and heavier guns led to heavier armor. And in the early 1900s, a naval arms race led to the creation of ocean-going behemoths of such size that they defied imagination. Battleships.
The battleship really, I suppose you could say, reached its zenith during World War I. It was a large steel ship, heavily armoured, fitted with big guns which could sling tons of shells towards an enemy battleship. Since then, battleships continued to be used through the Second World War, but more as large gun platforms than the traditional engagement between 2 battle fleets steaming in parallel, endeavouring to sink each other.
And in the Second World War, one of the biggest of those gun platforms was the American Iowa-class. World War II saw a shift in the shape of naval warfare. The Americans' new and fast Essex-class aircraft carriers had stolen the battleship's mantle as the capital ships of the fleet. But they needed vessels that could protect them at speeds in excess of 30 knots. The design challenge was to develop a battleship fast enough to keep pace, while also providing the firepower to combat the heavy Japanese vessels already constructed. At over 270 meters in length, and with a beam of 33 meters, everything about the Iowa-class was big. 8 water tube boilers, feeding 4 advanced steam turbines, gave the Iowa a top speed of over 33 knots. And to guard against torpedoes, the Iowa-class had a hull design that included an internal bulge, consisting of 4 longitudinal bulkheads behind the outer hull plating. With a depth of 5.5 meters, designed to absorb the energy of a torpedo warhead, protecting the superstructure. But a battleship is nothing without big guns, and the Iowa-class carried 9 massive Mark VII main guns, each with a caliber of 410 millimeters. Perhaps the most well-known of the Iowa-class was the USS Missouri, with the Japanese famously signing the surrender ending World War II on her deck on the 2nd of September 1945. Decommissioned a number of times before being brought back into service, first in Korea in the 1950s and again in the 60s, where her massive guns provided extra firepower in Vietnam. The Missouri was finally decommissioned in 1992 after being resurrected yet again during the First Gulf War. But not all battleships were survivors. Hitler, at one time, referred to the First World War German fleet as a romantic plaything, a parade piece. If Germany were to fight again, under Hitler, they would have a navy to be reckoned with. And by 1939, Germany boasted a modern fleet of staggering proportions. And the centerpiece of that fleet were 2 50,000-ton battleships, the Bismarck and the Tirpitz. The largest battleship class in Europe, these 250-meter-long behemoths had a top speed of 30 knots and a range in excess of 16,430 kilometers. In the Battle of Denmark Strait on the 24th of May, 1941, the Bismarck and the Prinz Eugen engaged the British battleships, the Prince of Wales and the Hood. After only 8 minutes of firing, the Hood took a hit in her rear ammunition magazine, and 100 tons of cordite exploded, breaking the ship's back. She quickly sunk, taking all but 3 of her crew of 1,419 men with her. The Prince of Wales was also damaged and laid a smokescreen to cover her withdrawal. In those 8 minutes, Bismarck had fired 93 armor-piercing shells and had been hit by 3 shells in return. One had struck the forecastle, and 2,000 tons of water flooded the ship, contaminating fuel oil stored in the bow. Forced to change course to seek repairs, the Bismarck was pursued by the Royal Navy. Over the ensuing 2 days, the German vessel took a surprising number of hits and still managed to evade her pursuers. And it was armor that was the key to the Bismarck's survival. Nearly half of the vessel's overall weight constituted protection to vital areas. At the belt line, it reached 320 millimeters thick. On the decks, 120 millimeters. And the main gun turrets were shrouded by steel 360 millimeters thick. What did it for her in the end were the machines that spelled the end of the battleship as a machine of war: aircraft. On the 26th of May, a flight of 15 Swordfish torpedo bombers launched an attack. Within just hours, the pride of the German fleet was sunk.
What's really fascinating about the action against the Bismarck was that the aircraft, the Swordfish, the most basic, simple little aircraft with torpedoes slung underneath it, operating from an aircraft carrier. I mean, the aircraft were technologically ancient.
The ship that launched those aircraft was one of a new type of warship that would hold sway for decades as one of the most powerful of all the machinery of war, and one of the biggest. The aircraft carrier. The British began using ships to carry aircraft in World War I. The first was the HMS Ark Royal, a heavily modified merchant ship that transported float planes in her hold, which were slung over the side using cranes. Despite not being a carrier as we know them, she introduced a number of features which are typical of aircraft carriers today.
An enclosed hangar, which contains the aircraft, a clear deck forward so that you could launch aircraft from there, and workshops to provide all the means of supporting those aircraft. The ship unfortunately only had a speed of about 10 knots, so she was not very capable of high-speed operations or real use as an aircraft carrier.
Those real, purpose-built aircraft carriers emerged in the 1930s. And in the early days of 1941, among the ships which gave chase to the Bismarck was one of them, also named Ark Royal, and launched in 1938. Far from being a converted merchant ship, HMS Ark Royal displayed the two most distinctive features of a modern aircraft carrier. A flat 240-meter flight deck that overhung the stern 20 meters above the waterline, and the familiar control tower island positioned on the starboard side. With armored hangars extending 3 stories below, the 50 aircraft that made up her strike weapons were raised to the deck by hydraulic lifts. Equipped with the now famous arrestor cables to catch the aircraft on landing, the Ark Royal used the latest steam catapult system to assist them at takeoff. With those aircraft comprising the Ark Royal's primary weapons, she was lightly armed. But with a top speed in excess of 30 knots, Britain's military planners believed they would be able to outrun most enemy ships if attacked. This thinking also led to the Ark Royal being relatively lightly armored. And it cost her. In November 1941, while sailing toward Gibraltar, the Ark Royal fell victim to the German U-boat U-81. Sunk by torpedoes, just as the Bismarck had been only months earlier. But where aircraft carriers really came into their own was in the vastness of the Pacific. And their experiences would change the face of warfare forever. One of the early lessons of the Second World War was that the rapid advances in aircraft performance and capabilities during the interwar years meant that command of the air became a prerequisite to success in land or sea engagements. The superior range, flexibility, and effectiveness of carrier-launched aircraft was no more ably demonstrated than on the morning of the 7th of December, 1941. When a Japanese task force that included 6 aircraft carriers attacked Pearl Harbor, and in a little over 2 hours, decimated the American Pacific Fleet. The U.S. immediately responded by declaring war on Japan and began planning a reprisal. What the Americans wished to do was attack the Japanese where they least expected it, on their own soil. And to do that, they drew on a growing understanding of the aircraft carrier's potential.
You can approach your enemy territory and exercise your influence by means of force with your aircraft from your ship. You don't need a land base. You don't need somebody else's territory to operate from. You can operate from your own ship in international waters.
The reprisal attack became known as the Doolittle Raid, and it was carried out using one of the new Yorktown-class aircraft carriers, the USS Hornet. The Hornet had a wartime complement of close to 3,000 and was capable of carrying a mix of 90 aircraft, including torpedo bombers, fighters, and dive bombers, giving her an unmatched ability to respond to all manner of situations. And in April 1942, she steamed towards Japan carrying a special unit of 16 highly modified B-25 Mitchell medium bombers, under the command of Colonel James Doolittle. Although none of the B-25 pilots, including Doolittle, had ever taken off from a carrier, on the morning of the 18th of April, in a heavy gale, all 16 aircraft launched safely, and from a distance of over 1,000 kilometers, began their journey towards Japan. The aircraft began arriving over Japanese cities at about noon, 6 hours after takeoff, and attacked military and industrial targets in Tokyo, Yokohama, and Osaka. None were shot down, but landing medium bombers on the Hornet's 245-meter flight deck would be impossible for the aircraft, which were deliberately ditched over China following the raid. All of the aircraft were lost, but all bar 11 crewmen emerged unscathed. The Doolittle raid was the first American attack on the Japanese homeland, and not only bolstered morale at home, but in demonstrating the reach of American naval and air power, it had a deep psychological effect on the enemy. It also marked the emergence of the aircraft carrier as the dominant force in the war in the Pacific. As aircraft grew in size and power, they also grew in consumption. And the Cold War prompted a desire for warships that could operate without restriction.
Now, of course, in the aircraft carrier, if you can provide the propulsive power without needing all fuel, you've got an advantage. And the nuclear reactor provides that advantage. You don't need to fuel the aircraft carrier for our own propulsion. And you can use the space which is freed up to carry fuel for the aircraft.
The first American nuclear carrier was the Enterprise class, which saw service for 50 years. It was followed by the NIMITZ. The NIMITZ class is over 330 meters in length, displaces 100,000 tons, and can carry its cargo of 90 aircraft, which are launched from a flight deck with a total area of over 18,000 square meters that sits 20 stories above the surrounding sea. And it cruises at 32 knots, a speed it can maintain for 25 years.
A warship does all its work at sea in any conditions. And a warship has to take the crew and the weapon systems to sea, keep the crew fed, fit, and working under any conditions, and to be able to fight under those conditions. This imposes considerable challenges on the way you design a warship and their survivability at sea.
Survivability was central to the NIMITZ design, and being powered by two modern and relatively small Westinghouse nuclear reactors allows a lot of hull space to be dedicated to that survivability. As such, over 14 million liters of aviation fuel is stored on board. Added to that is the capacity to stow over 3,000 tons of ordnance. The NIMITZ carries the latest in passive and active defense systems. However, the U.S. Navy still bears the scars of World War II. As a consequence, the aircraft hangars on board are divided into 3 fire bays on each level by thick steel doors that are designed to restrict the spread of fire. A feature present on all U.S. aircraft carriers since the devastating fires caused by kamikaze attacks over 70 years ago. The 10 NIMITZ-class aircraft carriers, once the largest warships on the planet, are one of the most devastating of all the machinery of war. Now, however, their mantle as the largest falls to the Gerald R. Ford class. Designed like the NIMITZ with a lifespan of 50 years, history suggests that her replacement will be even bigger.